Now that we have learned about the reference documents and why we are using them to start with for our alignment judgments, and about the essential questions and the structure of the physical science domain, let's jump into what it looks like for life science and earth and space science. Life science is our next big category, and it's divided into 4 core ideas. I've again listed the page numbers in the framework for each of those DCIs, and we'll go over 4 questions. And again, you will probably want to take some notes so that you can think about how this fits into your curriculum. If you cover topics in the life sciences area, our first core idea is for the molecules to organisms, the structures and processes. The overarching question for this core idea is, how do organisms live, grow, and respond to their environment and reproduce? The second core idea is for ecosystems, interactions, energy, and dynamics. The overarching question here is, how and why do organisms interact with their environments, and what are the effects of those interactions? The third core idea is the heredity, inheritance, and variation of traits. And the overarching question for this core idea is, how are characteristics of one generation passed on to the next? How can individuals of the same species and even siblings have different characteristics? And the fourth core idea is biological evolution, unity, and diversity. And the overarching question for this core idea is, how can there be so many different and so many similarities among organisms, yet so many different kinds of plants and animals and microorganisms? And how does biodiversity affect humans? Earth and space is our last category, as Montana did not adopt the engineering standards. However, that does not mean we cannot do anything with the engineering section. The Earth and space section is divided into 3 core ideas. I've listed the page numbers in the framework for each DCI. There is also an overarching question for each of the 3 Earth and space science core ideas. Again, you might want to take notes on your reference document to help conceptualize when, where, and why these topics are currently taught in your curriculum. The first core idea is Earth's place in the universe. And the overarching question is, what is the universe, and what is the Earth's place in it? The second core idea is Earth systems. The overarching question here is, how and why is Earth constantly changing? And the final core idea is Earth and human activity. This is where we ask, how do Earth's surface processes and human activities affect each other? For our formative development work, one thing you will need to consider is that if Montana did not adopt the engineering standards, do we want to follow this adoption rule with our online repository? Or do we want to provide examples for formative resources and assessments in engineering? We will come back to this consideration later on in the course. As teachers interact with the framework, a common topic of discussion is why some things have been included and highlighted on and others are not specifically mentioned. The authors created an articulated key criteria for inclusion in the framework. They required each DCI to meet at least 2 of these criteria, and they preferred that the DCIs meet 3 or 4 of the 4 criteria to be included. These were that the DCI must have broad importance across multiple sciences or engineering disciplines, or be a key organizing principle of a single discipline. It needed to provide a key tool for understanding or investigating more complex ideas and solving problems. It needed to relate to the interests and life experiences of students, or be connected to societal or personal concerns that require scientific or technological knowledge. Lastly, it needed to be teachable and learned over multiple grades at increasing levels of depth and made accessible to younger students, but broad enough to sustain continued investigation over the years. With these 4 DCI criteria, look at the items, sets of items, or resources that spark questions in you, either about inclusion or exclusion. Be mindful of the criteria, and think about the logic for focus, and how these would extend into our guidance for helping fellow science educators with this content in terms of what resources we develop and why. We will end this video with a framework quote. An education focused on a limited set of ideas and practices should enable students to continue their development well beyond their K-12 school years as science learners, users of scientific knowledge, and perhaps also producers of such knowledge. We need to be really sure that we're less focused on checking off content to cover everything we can possibly cover in a school year, and more focused in preparing students for this vision of lifelong learning.